Hello, student. How are you? I think all of you are well. This is your first class of IC class 11 chemistry. This is Latif sir. Today I'll discuss about the structure of atom, the second chapter of IC class 11. Okay. And one thing I want to mention that you have already studied huh, a portion about this chapter in class 9. Today, whatever I will discuss you have already studied in class 9. This is a basic part of structure of atom. Okay. And mm, no question will ask in the board exam from this portion. Okay, you have to remember that. So structure of atom, you know that atom is the smallest individual particles of matter. An atom is made up of proton, neutron and electrons. And you also know that you know that huh, electrons was discovered by J.J. Thomson, protons was discovered by Rutherford, and neutrons were discovered by James Chadwick. So you have to today I'll discuss about the discovery of proton, neutrons, and electrons. Okay, so electrons was discovered by J.J. Thomson, uh, and the name of the experiment is cathode ray experiment. So discovery of electron and cathode ray discharge tube experiment. So what is the discharge tube? This discharge tube looks like this. It is a glass made instrument. Huh. In this discharge tube, one cathode and one anode used, and in the discharge tube, very small amount of gas uh, were taken. Huh. That is, the pressure inside the discharge tube were very small. Okay, you have to remember this. Now let's see the experiment. A cathode ray discharge tube is discharge tube made up of glass is taken with two electrodes at very low pressure and high voltage. If you apply high voltage difference between the cathode and anode, you will see that a current flowing, or a light start flowing through a stream of particles moving in the tube from the cathode to anode, and these rays were called cathode rays. Which scientist did this experiment to discover electron? J.J. Thomson. Okay, you have to remember. So I have told what is what are the cathode rays. So cathode rays are the light, one type of light rays uh, flowing through a stream of particles moving in the tube from cathode to anode. These rays were called cathode rays. When a perforated anode was taken, the cathode rays struck the other end of the glass tube at the fluorescence coating, and a bright spot on the coating was developed. This was uh, the main experiment of cathode ray discharge tube. Now you have to know about the result of the cathode ray experiment. Hmm. So the results of cathode ray experiments are: cathode rays consist of negatively charged particles, or negatively charged particle, that means electrons. Uh, That's why cathode rays consist of negatively charged electrons. Second point, cathode rays themselves are not visible, but their behavior can be observed with the help of fluorescence or phosphorescent materials like zinc sulfide. Uh, Third point, in the absence of electrical or magnetic field, cathode rays travel in a straight line. But in presence of electrical or magnetic field, behavior of cathode rays is similar to that shown by electron. Actually, the cathode rays were attracted towards the positively charged electric field. That's why the charge of the particles present present in cathode rays are negative. That is, cathode rays are negatively charged, but consist of negatively charged electrons. Huh. That's why cathode rays were attracted towards positively charged electric field. Hmm. And next point, characteristic of cathode rays do not depend upon the material of electrodes and the nature of gas present in the cathode ray discharge tube. So characteristic of cathode ray do not depend on the nature of gas present in the discharge tube. And next point, the charge to mass ratio of cathode rays, that is electron. The mass charge to mass ratio of an electron, that is cathode rays, was determined by Thomson, and the charge to mass ratio of an electron is 1.758820 into 10 to the power 11 coulomb per kg, and this value never changes. That is, the charge to mass ratio of cathode rays always uh, remains same. Huh. Whatever the nature of gas used in the discharge tube, the charge to mass ratio of electron were always same, and the value of charge to mass ratio of cathode rays or the value of charge to mass ratio of an electron was 1.758820 into 10 to the power 11 coulomb per kg. And next point, charge of an electron was determined by Millikan. Which scientist was discovered the charge of electron? Answer is R.A. Millikan. Millikan. Okay. By using an experiment known as oil drop experiment. Okay. So scientist Millikan, using oil drop experiment, uh, uh, determine the charge of an electron, and the value of the charge of an electron is minus 1.6 into 10 to the power minus 19 coulomb, minus 1.6 into 10 to the minus 19 coulomb. And next point, the mass of an electron was determined by combining the result of Thomson's experiment and Millikan's oil drop experiment, and the mass of an electron was determined to be 9.1094 into 10 to the minus 31 kg, or simply you can say the mass of an electron is 9.1 into 10 to the minus 31 kg. Now discovery of proton, or and the experiment is canal ray experiment. Okay. See, like a cathode ray experiment, it is a canal ray experiment or canal ray. Discovery of protons. Huh. Modified, which scientist discovered? Uh, Initially, scientist Goldstein did the experiment, and finally Rutherford discovered protons. Okay. Modified cathode ray tube experiment was carried out, which led to the discovery of proton. Huh. So this is a discharge tube. The discovery of protons and electrons are almost similar. Huh. Cathode ray In cathode rays, electrons are present. In anode rays or canal rays, also called canal rays. Canal rays are consist of positively charged proton. Okay, but the experiment is same. Cathode ray Cathode rays moving from cathode to anode in the discharge tube, while anode rays or canal rays, sometimes called canal rays, are moving from anode to cathode. Okay, the experiment is similar in the discovery of uh, proton. Anode rays which contains positively charged protons. Okay, and it's moving from anode towards cathode, but cathode rays start moving from cathode towards anode. Okay, just direction are different. Now, characteristic of positively charged particles, that is characteristics of cathode rays, which contains positively charged particles, which uh, further identified that these particles were protons, positively charged protons. So, characteristic of positively charged particles. First, the charge to mass ratio of particles depends on the gas from which this originated. But the characteristic of the charge to mass ratio of cathode rays never depends on the nature of the gas, but the charge to mass ratio of particles, or positively charged particles, that is proton, depends on the nature of the gas used in the discharge tube. Hmm. The positively charged particles depends upon the nature of the gas present in the cathode rays discharge tube. Next one, some of the positively charged particles carry multiple of fundamental of electrical charge. Behavior of positively charged particles in electrical or magnetic field is opposite to that observed for cathode rays. Okay, that is, uh, the particles present in cathode rays and in anode rays both are both are of opposite charge. Okay, cathode ray is negatively charged electron, and anode ray is anode rays contains positively charged protons. Okay. Now, discovery of Newton. Which scientist discovered James Chadwick? Newton Newtons were discovered by James Chadwick by bombarding a thin sheet of beryllium by alpha particle. They are electrically neutral particles having a mass slightly greater than that of protons. Okay. Here in the table, you can see a summary of charge and mass of the protons, neutron, and electron. These are fundamental particles of an atom. Hmm. So, electron, first fundamental particle electron mass is 9.1 into 10 to the minus 31 kg. Charge of electron is minus 1.6 into 10 to the minus 19 coulomb. And relative value mass 1 by 1 1837 part of mass of one proton. Mass of electron is 1 by 1837 part of an mass of proton. Okay, and relative value of charge of electron is minus 1. Hmm. Second, proton. Absolute value of mass of proton is 1.67252 into 10 to the minus 27 kg, and the absolute charge of proton is plus 1.6022 into 10 to the minus 19 coulomb, but the relative mass of proton is 1 and relative charge of proton is plus 1. And uh, now neutron, the mass of neutron is 1.67495 into 10 to the minus 27 kg, and the charge of neutron is 0, and the relative mass of neutron is 1 or 1.00145, and relative charge of neutron is 0. From this table it is clear that neutron is slightly heavier than proton, and that is, neutron is the heaviest particle present in an atom. Okay, and the charge of proton and electron are same but opposite sign. Okay, now atomic number, you know that you have already studied in class 9. Atomic number is the number of protons present in the nucleus. Which scientist discovered atomic number? Henry Moseley in 1913. And mass number is the sum of number of protons and number of neutrons present in the nucleus. Okay, now Thomson model of an atom. Thomson first proposed uh, a model of an atomic model, and this model proposed that atom is considered as a uniform positively charged sphere and electrons were embedded in it. In Thomson atomic model or Thomson model of an atom, uh, it is considered that atom is considered as a uniform positively charged sphere and electrons are embedded in it. An important feature of Thomson model of an atom was that mass of an atom is considered to be evenly spread over the atom. And Thomson model of an atom, also called palm pudding or watermelon model. Thomson model of atom was discarded because it could not explain certain experimental results like scattering of alpha particle by thin metal foils. So Thomson atomic model was uh, discarded because uh, Thomson atomic model was not uh, could not explain certain experimental result. Okay, later Rutherford give atomic model on the basis of alpha particle scattering experiment. So now you have to read about Rutherford's alpha particle experiment, scattering experiment. You know that you have already studied in class 9. And this this was the Rutherford experimental setup, alpha particle scattering experiment. Hmm. Here you can see source of alpha particles, and alpha particle strike on the thin gold foil, hmm, and maximum alpha particle, you know that, maximum alpha particle uh, pass through the thin gold foil to the opposite side of the gold foil. Okay, so observation of alpha particle experiment, you have to first see the figure 2.8. An alpha particle is deviated when it comes close to the nucleus, and maximum alpha particles pass through the uh, thin gold foil or pass through the uh, atoms present in the thin gold foils. Okay, so conclusion or observation of alpha particle experiment where most of alpha particle pass through the gold foil undeflected, and a small fraction of alpha particles got deflected through small angles, and very few alpha particles did not pass through the gold foil, huh, but suffered large deflection nearly 180 degree. Very few alpha particles did not pass through the foil, and they deflected through an angle 180 degree, huh, because these particles directly collide with the positively charged nucleus. Okay, that's why very few alpha particles were deflected through an angle 180 degree, and maximum alpha particles were passed through the atom. From this point, it is clear that conclusion of or Rutherford experiment, alpha particle scattering experiment, since most of alpha particle pass through the gold foil undeflected, it means most of the space in atom is empty. So conclusions of Rutherford alpha particle scattering experiments were, since most of alpha particles pass through foil undeflected, it means most of space in an atom is empty. Since some of alpha particles are deflected to certain angles, it means that there is positively charged mass present in the nucleus, in the center of an atom, which is called nucleus. Since some of the alpha particles are deflected to some certain angles, it means that there is positively charged mass present in an atom. Since only some of the alpha particles suffered large deflection, that is deflection through an angle 180 degree, the positively charged mass must be present, must be occupying very small space at the center of the atom, which is called nucleus. Okay, and strong deflection or even bouncing back of alpha particle from the metal foil were due to the direct collision with the positively charged mass in the center of the atom, which is called nucleus. I am again saying that. Okay, so this were the conclusion of alpha particle experiment of rather scattering experiment of Rutherford. Now Rutherford atomic model, and this model explained that atom consist of nucleus which is concentrated in a very small volume, and the nucleus comprises of protons and neutrons, and the electrons revolve around the nucleus in fixed orbits. Electrons revolve around the nucleus in fixed orbits. Electrons and nucleus are held together by strong electrostatic force of attraction. This was Rutherford atomic model or model of atom. And there were some drawback of Rutherford atomic model. Okay. According and the drawbacks of Rutherford models atomic model were according to Rutherford model of an atom, electrons which are negatively charged particles revolve around the nucleus in fixed orbits. Thus, electrons undergoes acceleration. Now, according to electromagnetic theory of Maxwell, a charged particle undergoing acceleration should emit electromagnetic radiations. According to magnetic theory of Maxwell, a charged particle undergoing acceleration should emit electromagnetic radiation. Thus, an electron in an orbit should emit radiation. Thus, the orbit should shrink, but this does not happen. Huh. This was the first drawback of Rutherford experiment, Rutherford atomic model. And second drawback of Rutherford atomic model, the model does not give any information about how electrons are distributed around the nucleus and what are energies of these electrons. The model does not give any information about how electrons are distributed around the nucleus and what are the energies of these electrons. And one more drawback of Rutherford experiment atomic model was that uh, it could not explain the formation huh, of line spectrum huh, or discrete spectrum of atom. Okay. Now isotope, these are the atoms of same element having the same atomic number but different mass number. Example, 1H1, 1H2, 1H3. These are three isotopes of hydrogen. Isotopes are of same elements. Okay, atoms of same elements having same atomic number but different mass number called isotopes. Isobars are the atoms of different element having same mass number but different atomic number. Example, 18 argon 40 and 20 calcium 40. Huh. These two are example of isobar because their mass number are same. Huh. Here the mass number of argon and calcium uh, is 40, but their atomic number are different. Atomic number of argon is 18 and atomic number of calcium is 20. So these are example of isobar. And isoelectric species, these are those species which have same number of electrons. Okay, thank you. This is today whatever I have told. This is a basic part of this chapter, and you have to revise this portion because you have already studied in class 9, and no question will ask from this portion in the final exam. Okay, but you have to read, you have to know about this fact, about discovery of proton, discovery of Newton. You have to know the name of scientists who discovered proton, Newton, electron, and most yeah, important is the charge of proton, charge of electron, charge of Newton, mass of proton, mass of electron, mass of Newton. You have to always remember this point, okay, because these are important. You have to remember the charge, mass of different particles, proton, Newton, electrons, and the name of the scientist who discovered proton, Newton, electrons. Okay, thank you.